Our next reaction is oxidation. These are oxidation reactions of carbonyl compounds. Not all carbonyl compounds I am emphasizing are aldehydes. Yeah, oxidation reactions of carbonyl compounds, which are aldehydes. Why ketones? Ketones are not this very well. This is critical and important in practicals. Ketones are not oxidized at all conditions. What I mean by saying at all conditions, ketones are not oxidized. They are neither, I repeat, they are neither oxidized by both mild and strong oxidizing agents. Why? Ketones are not oxidized because the first reason, there are around two reasons. Because, first of all, earlier on we saw that because they are very stable. They are very stable as compared to aldehydes. I explained this previously. If you are watching this video for the first time, I'll refer you to the previous lessons here. We explained that ketones are very stable as compared to aldehydes. Yeah, because they are having bulk groups bonded to carbon, the carbon atom. Yeah, that's why they are very stable as compared to aldehydes. Then the other things, they are very stable as compared to aldehydes. They also lack a hydrogen atom. They lack a hydrogen atom bonded to. They lack a hydrogen atom bonded to what? Bonded to the carbonyl carbon. They do not have, ketones have this structure, R, C, double bond, OR. That's how ketones look like. However, aldehydes, for them, they have R, C, double bond with oxygen, then H. So they lack a hydrogen atom bonded to the carbonyl carbon. They lack hydrogen atom bonded to the carbonyl carbon. Hence, therefore, this implies that they cannot undergo redox reactions. Yeah. For oxidation, I have called it oxidation. I have termed it as oxidation. But as we proceed, you are going to see that this is reduction and oxidation. So we are going to see that the carbonyl compound is oxidized. The carbonyl compound is oxidized as it reduces the oxidizing agent, like that. So aldehydes, for them, aldehydes, they have this hydrogen. So they are oxidized by oxidizing agents. They are oxidized by oxidizing agents. So if they are oxidized, for them, since they have this hydrogen here, they can in turn reduce those things which have oxidized them. Yeah. For ketones, since they do not lack this hydrogen, since they do not have this hydrogen, they cannot reduce those things which have oxidized them. It's like I have said, the reaction, I have termed it as oxidation, but we are going to see that it is redox. Why? The aldehyde is oxidized. Okay. Then after it being oxidized, then itself, the aldehyde, it reduces that thing which has oxidized it. It's like if I punch you, if I slap you, you slap back. Don't do that. Don't try that. Otherwise, you will regret for your entire life. So that is the reaction. I think it is Newton's study of motion. If I slap you, you can react by getting annoyed, only that, but don't think about any other reaction. Yeah, so that is the oxidation I am meaning. So correctly, it is supposed to be written as redox, but as of now, I have noted it as oxidation for my own reasons here. But just know that this aldehyde is oxidized. Once it is oxidized, then for it reduces that thing which has oxidized it. Now, for ketones, they cannot do that thing of reducing because they lack that hydrogen. Yeah, so by the way, we are also going to see that since ketones cannot be oxidized and aldehydes are oxidized, the two can be distinguished. We shall see that later. So what are we saying here? Aldehydes, I have explained why ketones are not oxidized. Aldehydes are oxidized by both mild and strong oxidizing agents. Whether I have a mild, I mean a weak oxidizing agent. Whether I have a weak oxidizing agent or strong oxidizing agent, the aldehyde is oxidized to carboxylic acid. So what are some of the examples of mild oxidizing agents? The weak oxidizing agents of consideration, they include, we have acidified manganese for oxide and heat. I am emphasizing that. Yeah. I am quoting a lot of reagents, but they are those which I am emphasizing. So weak oxidizing agents like acidified manganese for oxide and heat, and I am emphasizing that. Then we can also have limited acidified potassium dichromate 6 solution and heat, limited acidified chromium 6 oxide and heat. Those are some of the examples. However, for those of you who read a lot of books, you find others. There is the copper metal at 300 degrees centigrade, you find others. But I have emphasized only acidified manganese for oxide. Now, for strong oxidizing agents, I emphasize both of them. You shouldn't forget these oxidizing agents. Acidified potassium manganate 7 solution and heat, and excess acidified potassium dichromate 6 solution and heat. So all those oxidizing agents which I have highlighted, they oxidize aldehydes to carboxylic acids. And these are the general equations. So generally, we have for weak oxidizing agents, RCHO, RCHO. These are the weak oxidizing agents I have highlighted. Acidified. Now there is something which I need to highlight before we go any further. Let me in fact first remove this. Acidified. You may think of other acids, not the capital letters, not. When I say acidified, if I say acidified potassium, if I say acidified potassium manganate, if I say acidified potassium manganate 7 solution, acidified potassium manganate 7 solution, this means, it means potassium, it means potassium manganate. Potassium manganate 7 solution. Potassium manganate 7 solution. Acidified with dilute sulfuric acid. Acidified with dilute acid. Not any other acid. I wanted to make this clear. Like for condensation reactions of carbonyl compounds. You recall for condensation reactions of carbonyl compounds, we are acidifying to have a catalyst. We are acidifying using dilute sulfuric acid. And this was emphasized in the old curriculum, the old course outline. The old course outline, it was emphasized. We are following, if you mention acidified potassium manganate 7 solution, that was not appropriate. It wasn't appropriate. So however, for this new course outline, those things may may be ignored. Yeah, I don't know. You are the first cohort, so I also don't know how you will be graded. Yeah, but we used to emphasize this thing. If I say acidified, I don't mean acidified with dilute hydrochloric acid or nitric acid. Please take note of this. Acidified anything, acidified manganese 4 oxide, acidified chromium 6 oxide, I mean something acidified with dilute sulfuric acid. Acidified with dilute sulfuric acid. Yeah. Now I can work out my examples. So for mild oxidizing agents, for mild oxidizing agents, what do we have? We have RCHO. RCHO, it is oxidized to a carboxylic acid. You know what oxidation means? Oxidation, addition of oxygen. So we add oxygen, addition of oxygen. So what are some of the examples of mild oxidizing agents? Manganese 4 oxide acidified with dilute sulfuric acid. Manganese 4 oxide acidified with dilute sulfuric acid on heat. Then we also have now here I don't have space. We also have what? Limited acidified chromate 6 oxide. Chromate 6 oxide acidified with dilute sulfuric acid. Yeah. However, for the mild, don't forget, remember that I have emphasized the first one, that one, manganese oxide. So we can also have RCHO with the limited acidified potassium dichromate 6 heat, add oxygen. You get a carboxylic acid. So those are the mild oxidizing agents. Those are the mild oxidizing agents which I have considered. There are 3: acidified manganese 4 oxide and heat, limited dichromate 6 and heat, and chromium 6 oxide and heat. Then for strong oxidizing agents, this is for strong oxidizing agents. Strong oxidizing agents. The strong oxidizing agents, I am emphasizing two strong oxidizing agents. So we have RCHO and the potassium dichromate 6. And the potassium dichromate 6 acidified with dilute sulfuric acid. And the potassium dichromate 6 acidified with it. Now without excess, it is still fine without excess. Yeah, without excess, it is still okay. Then if you have also some books you find excess chromium 6 oxide. Excess chromium 6 oxide acidified with dilute sulfuric acid. This is still okay. Excess chromium 6 oxide acidified with dilute sulfuric acid is still okay. Then also if you have acidified potassium manganate 7 solution, heat. This is still okay. Now, in some books, you will not find that K there. It is still fine. You'll find dichromate 6 written in terms of ions because it is in a solution. This is a solution. So in a solution, we have ions. It is still fine. Yeah. That's why I'm adding AQ there. It's still fine. So that is what we have for strong oxidizing agents. Yeah. I can take some specific examples now that I have formulated general equations. So examples. If I have ethanol with acidified potassium permanganate, heat, we get add oxygen, we get ethanoic acid. Then if I have propanol with acidified potassium permanganate acidified with dilute sulfuric acid, heat. What do you get? Add oxygen, propanoic acid. Then if I have, what else? If I have benzaldehyde with acidified chromium 6 oxide acidified with dilute sulfuric acid. Chromium 6 oxide acidified with dilute sulfuric acid on heating, you get benzoic acid. Simply add oxygen. So you see, I think I have taken a lot of examples. If I have cyclohexanol with the acidified potassium dichromate 6, heat. I add oxygen so that you get cyclohexanoic acid. Yeah, there are a lot of examples which can be formulated. Yeah, those are enough. Yeah. Don't forget that I have emphasized two strong oxidizing agents. I have emphasized two strong oxidizing agents. Potassium manganate 7 solution acidified with dilute sulfuric acid. Two strong potassium manganate 7 solution acidified with dilute sulfuric acid, and potassium dichromate 6 solution acidified with the dilute sulfuric acid. Those reactions occur in presence of heat. Yeah, see? Yeah. Then mild, I have emphasized one. Mild, I have emphasized one. Yeah. Now, I think we have seen that. Let me repeat this here. Note, I have said, once we say acidified here, we can have a lot of acidifications. Acidified, etc. This I mean something acidified with the dilute sulfuric acid. Then I have also mentioned that, what else? I've also mentioned that ketones are not oxidized. Ketones are not oxidized due to due to the reasons above, which I highlight. Yeah. Now, alternatively, those equations, alternatively, the equations above, can be formulated as follows. Equations above can be formulated as follows. Yeah.